You know, there's this very specific, almost universal kind of heartbreak in the modern tech world.
Absolutely, the new laptop heartbreak.
Right. You start a new job, or maybe your company just rolls out this massive draconian security update, and you get handed this beautiful top-of-the-line laptop.
Like pristine hardware, the best specs.
Exactly. And then you try to actually do your job. You go to open your terminal or, fire up a local container, and instead of working, you hit a wall.
Permission denied. Blocked by administrator.
It is the worst. It's like being handed the keys to a sports car, right? But the steering wheel is bolted straight, and you're only allowed to drive it in a school zone.
Yeah, it just forces your workflow to an absolute halt. I mean, developers rely on their local machines as personal workshops.
Yeah, you need to tinker.
Right, and when corporate IT strictly locks down that local environment, you can't compile, you can't test, and you definitely can't move fast. You're basically left with a very expensive web browsing machine.
And that frustration, that feeling of being totally trapped by the exact hardware you need to do your job, that is exactly what we're tackling today.
It's a huge issue for so many people.
It really is. So if you are listening to this deep dive right now, you have probably hit that exact wall. And our mission today is to explore a really fascinating guide created by the creator, Ebola Gunlana.
Yeah, it's a brilliant piece of work.
It really is masterclass.
Yep.
We're looking at how to use AWS CloudShell as this powerful, full-fledged alternative when your local laptop environment is totally locked down.
The whole premise is basically your laptop can't stop you.
Right. We are mapping out the ultimate cloud-based escape hatch today.
Yeah.
So what exactly are we looking at with this source material?
So the guide itself is laid out as a highly structured 10-part breakdown. Visually, it was originally designed as a swipeable document.
Oh, nice.
Yeah, it has this very cool, dark tech aesthetic, AWS Amber accents, monospace code elements, very slick. But, I mean, beneath the visuals, it is a deeply tactical dossier. It treats the corporate laptop lockdown not as a dead end, but just as a routing problem.
A routing problem. I like that. But before we get into the crazy cloud ninja moves, let's define the exact roadblocks first.
Yeah, we have to know what we're up against.
Right. So the guide opens with this section called the lockdown problem. And it visualizes it with these stark, crossed-out lock icons.
The red X badges, yeah.
Exactly.
Yeah.
Over 5 essential developer tools. So it doesn't just vague post about things being blocked. It points to the specific casualties of corporate endpoint security.
Right, because when IT locks down a laptop, they're not trying to ruin your day.
Even if it feels like it.
Right. I mean, they are just trying to secure the endpoint from vulnerabilities, malware, data exfiltration. But the collateral damage hits the exact tools a developer needs.
So what are those 5 specific tools the guide highlights?
Well, first is local Docker and container runtimes.
Huge loss.
Massive. And IT blocks this because local Docker daemons often require root privileges, which is obviously a massive security risk on a standard local laptop.
Right. That makes sense. What's the second one?
Administrative terminal access. So no sudo privileges for you.
Oh, man. Goodbye, power user status.
Exactly. Third is local package managers. So think Homebrew on a Mac or apt on Linux.
Wait, so you can't even install the libraries you need?
Nope, blocked.
Yeah.
Fourth, direct database clients. IT really doesn't want your physical laptop connecting directly to a production or even a staging database.
Yeah, I guess from a networking perspective, that's a nightmare for them.
Totally. And the fifth one is local web servers or testing environments. They just shut those ports down.
So just to recap, you lose your runtime, your admin rights, your software supply chain, your data access, and your testing arena.
Basically.
All in one single policy update. Your machine literally just becomes a read-only terminal.
Which brings us to the proposed solution, right? AWS CloudShell.
Let's talk about CloudShell.
So the guide lays out this what is CloudShell spec grid, just to establish the raw capabilities of our little escape hatch here.
What are the specs?
So we're looking at an Amazon Linux 2 operating system. For compute power, it gives you 1 vCPU and 2 gigabytes of RAM.
Okay. I mean, that's not exactly a supercomputer.
It's not, no.
Right, yeah.
But the cost is entirely free within the AWS tier.
Free is always good.
Right. But the real game changers are the last 3 specs on the grid. It handles authentication automatically, it has Docker pre-installed, and it supports VPC capabilities out of the box.
Okay, wait, let me stop you at the authentication part.
Sure.
Say it handles it automatically. Do you mean I don't have to generate access keys on my lockdown laptop?
Exactly.
Because normally you try to save them in some hidden file and
Well,
just pray the corporate security scanner doesn't flag them.
you don't have to do any of that. CloudShell actually inherits the exact permissions of the AWS console session you are currently logged into. Yeah, so if you authenticate into your AWS account via your web browser, which IT generally allows, right?
Yeah, they usually don't block the browser.
Right. So CloudShell just automatically assumes that IAM role. You bypass local credential management entirely.
Okay, so let me run an analogy by you. If my physical laptop is a locked room, CloudShell isn't just like a burner phone I smuggled in. It's more like IT bolted the doors on my physical office, but accidentally left me a functioning teleporter to a fully equipped secret lab inside the corporate headquarters.
That is a perfect analogy. The teleporter concept works so well, especially because of those Docker and VPC capabilities.
Right, because it's not just a toy environment.
Exactly. It's not just some lightweight scratchpad. Because Docker is pre-installed, you can pull images, build containers, run complex multi-tier apps directly in this shell.
That is wild.
Yeah, it literally has the raw materials to completely rebuild your local development environment. It's just hosted in the cloud instead of on your desk.
But, knowing the specs is one thing. Actually, porting your workflow over is a whole different beast.
Right, the transition is the hard part.
And the guide introduces this thing called the replacement map to bridge that gap. It doesn't just say, hey, use CloudShell.
No, it's much more practical than that.
It puts those 5 blocked local tools side by side with their direct CloudShell solutions, right?
Exactly. It maps out a strict one-to-one transition. So your local Docker desktop that IT blocked,
Ooh.
you replace that by running the Docker daemon natively inside CloudShell.
Makes sense.
You lost your local package manager. Well, use the Amazon Linux Yum package manager, which is available right in the CloudShell terminal.
Oh, so you get your supply chain back.
You do. And you can't use your local database client like dbeaver or Datagrip.
Right.
You just use the CloudShell command line interface to securely query the database directly. It takes this abstract idea of working in the cloud and grounds it in very practical substitution.
It really takes the guesswork out of it. But okay, the guide then introduces a massive architectural shift, something it calls VPC mode.
Yes, this is a huge part of the strategy.
Right, and it provides a full architecture diagram for this. Now, for anyone listening, a VPC is a virtual private cloud. It's a logically isolated network within AWS.
Correct.
But if I'm a developer, I have to be a little skeptical here. Aren't we just trading one set of handcuffs for another?
How do you mean?
Well, if I attach my CloudShell to a VPC, I am deliberately locking myself inside a walled garden.
That's true.
I might have to deal with complex routing rules, or, my outbound internet access might get restricted. Why would I volunteer to work inside another cage?
I get that. You're touching on the fundamental compromise of enterprise cloud development here.
Right.
Yes, operating in VPC mode introduces new constraints. You might actually lose the ability to easily hit public APIs if that specific VPC doesn't have a NAT gateway configured.
Which is super annoying.
It is, but we have to look at why the guide mandates this structure. Think about it. IT locked down your laptop to keep the corporate network safe. Yeah.
By
running CloudShell in VPC mode, you are placing your secure, fully featured workbench directly inside the company's approved perimeter.
Okay. So I am inside the fortress now.
You are inside the fortress, and because you are inside, you have the operational freedom to interact directly with internal databases, private APIs, microservices.
Stuff my lockdown laptop over on the office guest Wi-Fi could never, ever reach.
Exactly. If you didn't use VPC mode, your CloudShell would just be sitting out on the public internet. It would be completely cut off from your company's actual internal infrastructure.
Oh, I see. So it's a strategic compromise.
Right. You accept the boundaries of the VPC network, and in return, IT basically gives you back your development environment.
That actually makes perfect sense. You stop trying to poke holes in the corporate firewall from the outside, and you just do your work securely on the inside.
Precisely.
But doesn't that create a new operational problem?
It does.
Because, okay, if I am running a local development server inside this isolated VPC CloudShell, how do I actually see it?
Right, the visual problem.
Yeah, if I spin up a web app on port 8080 inside CloudShell, I can't just type localhost punt 8080 into my physical laptop's web browser. My laptop is not in the VPC.
And this is exactly where the guide moves from basic workarounds to real advanced operational techniques.
Okay, lay it on me.
It introduces a major concept called SSM port forwarding.
SSM.
Yeah, SSM stands for AWS Systems Manager. The guide provides the specific terminal code blocks required to set this up. And it focuses heavily on a concept it calls the bastionless pattern.
Let's unpack that, the
Yeah.
bastionless pattern.
Yeah.
Because a bastion host, or, a jump box, is traditionally this dedicated server sitting right on the edge of a VPC.
The traditional gatekeeper.
Exactly. If I want to access an internal database, I have to SSH into the bastion first and then hop from the bastion to the database.
It's tedious.
It is notorious for being a clunky bottleneck.
Yeah.
You have to manage SSH keys, which honestly, your locked-down laptop might not even let you generate.
Very true.
And if the bastion server goes down, nobody can work.
Yeah.
So by using SSM port forwarding, wait, are we completely skipping the traditional jump box bottleneck? Are we just tunneling straight in?
Yes, we are enthusiastically eliminating the bastion host entirely.
That is amazing.
It really is. See, SSM works very differently than traditional SSH. Traditional SSH requires opening port 22 on the network firewall.
And security teams absolutely hate doing
They
that.
despise it. But SSM uses an agent installed on the AWS resources. And it creates an outbound WebSocket connection over port 443.
Which is just standard HTTPS traffic.
Exactly. Because it uses standard web traffic ports, it just sails right through most corporate firewalls without triggering any alarms.
Okay, so just to make sure I have this straight, I run a specific AWS CLI command on my laptop, and it creates a secure encrypted tunnel directly from my laptop's local port, straight through the cloud, and into my CloudShell environment running in the VPC.
That is exactly how it works. You run the command, and suddenly, typing localhost 0.808 in your laptop's browser seamlessly routes you to the application running inside the CloudShell VPC.
That is massive.
Yeah.
No SSH keys to manage,
Yeah.
no jump boxes to maintain,
None.
and no port 22 required.
It's beautifully elegant.
And the guide structures this as part of its 6 power patterns, right?
Yes, the 6 power patterns.
These aren't just like one-off tricks.
Yeah.
They're a numbered framework designed to make CloudShell a viable daily driver environment.
They really tie the whole workflow together.
We've already hit on a few of these implicitly, but let's just lay them all out for the listener.
Sure. So the patterns synthesize everything into repeatable workflows. Pattern 1 is the IAM inheritor. That's using your browser's console login to instantly pass credentials to your shell, completely bypassing local key storage. Pattern 2 is the ephemeral container. That's leveraging the built-in Docker engine to pull and run complex dependencies without having to beg IT to install them locally.
Right, and pattern 3 would be the VPC teleport, attaching your shell directly to the internal network to access private databases without navigating clunky corporate VPNs.
Exactly. Which brings us to pattern 4, the crown jewel we just discussed. The bastionless tunnel.
Using SSM port forwarding to securely map remote resources to your local machine.
You got it. And that naturally leads to pattern 5, the local host illusion.
Oh, I love that name.
It's great, right? This is the practical application of the tunnel. It's where you test web apps in your local browser while the actual compute power is happening securely in the cloud.
Which feels like magic.
It really does. And finally, pattern 6 is the headless workspace.
What does that entail?
Well, because you are operating purely in a terminal, you need to utilize tools like VPC-mode.
Oh, terminal multiplexers.
Right. You use them to keep your sessions running in the background. It lets you manage multiple windows and processes without needing a heavy graphical IDE on your local machine.
These 6 patterns, they just completely shift the paradigm.
They really do. You stop fighting your hardware.
Right, you are no longer fighting the laptop.
Yeah.
You are bypassing it using the cloud's native management tools.
Mm-hmm.
But, okay, here comes the reality check.
There's always a catch.
There has to be a catch.
Mm-hmm.
With all this bastionless access and an entire cloud environment sitting just a browser tab away, what are the limitations? And the guide doesn't hide this, right?
No, the guide is very upfront. It actually dedicates an entire section to hard limits.
Right.
And visually, the source document shifts to this stark red warning
The
theme.
red flag section.
Exactly. The shift to red is a necessary wake-up call. You have to understand the physical constraints of a managed shell environment. CloudShell is not a permanent, always-on EC2 server.
It's not a permanent desktop.
No, it is an ephemeral compute environment.
Okay, let's talk about the specific walls the user will inevitably hit. What's the first big one?
The first major wall is persistent storage. CloudShell provides exactly 1 gigabyte of persistent storage.
Oh, wow. 1 gigabyte. That is tiny.
It is very small, And worse, it is strictly limited to your home directory.
Wait. So if I install a software package that writes to the root directory, like the var or etc. folder.
It vanishes the exact moment your session ends.
You are kidding.
No, only the contents of the home CloudShell user directory are actually saved between sessions.
Yeah.
Everything else is wiped.
So if you try to pull a massive 5 GB database dump into your shell, you are just going to hit a hard failure.
Exactly. You will just run out of space immediately. And the second rule is the session timeout constraint.
How bad is that?
Well, CloudShell is designed for transient work. So if you step away from your keyboard for 20 to 30 minutes, the shell just times out.
Just 20 minutes.
Yeah. The instance is recycled. Any running processes, background tasks, or active Docker containers are immediately terminated.
Wow. Okay, so you really have to treat CloudShell like a hotel room, not your permanent residence.
That's a great way to think about it.
You can work there all day, but you have to pack your bags and push your code to a Git repository before you leave for lunch. Otherwise, the cleaning staff is going straight in and throwing everything in the trash.
That is the exact operational discipline required. You have to commit your code constantly.
That's stressful, but manageable.
Right. But beyond just the operational limits, the guide tackles a concept that is critical for anyone actually deploying this in an enterprise environment.
Let's hear it.
It brings up the security gotcha. Specifically, it breaks down the concept of CloudTrail blind spots.
Okay, stop right there. If I am a corporate security administrator listening to this deep dive right now, the phrase CloudTrail blind spots sounds like an absolute nightmare.
It definitely raises the blood pressure. Seriously. CloudTrail is the AWS service that acts as the ultimate surveillance camera. It logs every single API activity. If I spin up a server or modify a database table, CloudTrail logs exactly who did it, from what IP address, and at what time.
It's the gold standard for auditing.
Right. So are you saying developers using this CloudShell workaround are essentially flying blind? Like, are they hiding their activities from the security team?
It's vital to understand the mechanism behind this blind spot.
Yeah.
So CloudTrail is phenomenal at monitoring the AWS control plane.
The control plane?
Yes. It sees the API calls. So when you click the button to launch CloudShell, CloudTrail logs it. They know you started a session, but once you are actually inside the CloudShell environment, you're operating on the compute data plane.
Meaning the internal actions within the shell itself.
Exactly. When you're inside CloudShell, typing else to list files or running a Python script, compiling code, or even running Docker build.
Wait, none of that is tracked. None of it. Because those are local compute processes happening inside the isolated virtual machine. They do not trigger AWS API calls, which means they do not get sent to CloudTrail.
Oh, wow. So to use another analogy, the perimeter of the building is heavily monitored by security cameras.
Right.
They know exactly what time you scanned your badge and entered the room.
Yeah.
But there are literally 0 cameras inside the room itself.
That captures it perfectly. In a traditional corporate setup, IT installs endpoint monitoring software directly on your physical laptop.
Oh yeah, like CrowdStrike or a Sentinel.
Exactly. And those tools can see every single process running on your machine. But when you move your entire workflow into CloudShell, you strip away that local endpoint visibility. IT cannot see the internal keystrokes anymore.
That is a massive security trade-off.
It is a huge blind spot.
How does the guide address this? Because it can't just tell developers, hey, good luck, don't get caught bypassing your security team.
No, not at all. The guide is very responsible here. It heavily emphasizes detection tips, making it clear that mitigating this risk is a non-negotiable part of the framework.
You have to play nice with security.
You have to. You cannot just adopt the power without adopting the responsibility.
Yeah.
Since security teams can no longer rely on local laptop process monitoring, they just have to shift their posture.
So what should they actually be looking for if they can't see the keystrokes?
They need to monitor the boundary of the VPC. The guide suggests implementing VPC flow logs.
What do those do?
They capture metadata about all the IP traffic going to and from network interfaces inside the VPC. So even if security can't see the specific Docker command you ran inside the shell, flow logs will instantly alert them if your CloudShell environment suddenly tries to download gigabytes of data from an unknown external IP address.
Oh, I see. So they watch the network exhaust instead of the engine itself.
Exactly. And security also needs to strictly monitor the IAM role attached to the CloudShell if that specific role suddenly starts making anomalous API calls.
Like trying to delete S3 buckets it shouldn't have access to.
Right, that would trigger an immediate alert. You maintain security by monitoring the network exhaust and the API permissions rather than tracking individual keystrokes on the machine.
It requires a more modernized security posture, for sure. But it proves that developer freedom and corporate security don't have to be mutually exclusive.
Not at all.
You just have to know how to architect the solution. So what does this all mean for you, the listener? We have unpacked a massive paradigm shift today.
We covered a lot of ground.
We really did. We started with the harsh reality of a local laptop that felt like a brick, locked down by IT, stripping you of essential tools like Docker, package managers, admin access.
The worst feeling.
And we explored how this guide by Bologanlana maps out an escape hatch using AWS CloudShell, leveraging its built-in compute, automatic authentication, and native Docker support.
We walked through the replacement map, proving you can actually swap out blocked local tools for cloud-native solutions point for point, and we tackled the strategic compromise of VPC-mode. Understanding that stepping inside that walled garden gives you secure, direct access to the internal resources you actually need to do your job.
Right. And then we unlocked the true potential of the environment with those 6 power patterns. We saw how the bastionless tunnel, powered by SSM port forwarding, uses WebSockets over port 443 to punch securely through corporate firewalls.
Eliminating the absolute nightmare of jump boxes and SSH keys.
So satisfying. But we also grounded the strategy with the hard limits, right? Acknowledging the strict 1 GB storage cap and those ruthless session timeouts.
You have to be prepared for those.
And crucially, we addressed the CloudTrail blind spots, understanding that the transition from endpoint monitoring to VPC network monitoring is non-negotiable for keeping the enterprise secure.
It is a brilliantly comprehensive framework. And, the way this knowledge is being distributed is worth noting, too.
Oh, definitely.
By publishing this guide as a native swipeable PDF document on LinkedIn, it leverages the platform's algorithm to render as an interactive carousel.
It's so smart. It takes complex, high-level cloud architecture and makes it highly visual and immediately actionable.
Right. It totally bypasses the traditional dry technical blog post. The visual cues, the specific code blocks, the structured constraints. It just makes the technical concepts much easier to digest and deploy in the real world.
If you are dealing with a lockdown machine right now and you want to see this architectural breakdown for yourself, check the blog link in the original post. And definitely follow the creator at Bologanlana for more high-level cloud strategies.
Highly recommend checking it out.
To wrap things up today, I want to leave you with a lingering thought. We started by talking about the heartbreak of the pristine, completely useless corporate laptop.
The brick.
The brick. But if developers are routinely forced to architect complex, brilliant workarounds like this CloudShell framework just to perform their basic daily tasks, does the traditional model of the hyper-locked-down physical laptop even make sense anymore? If the actual compute, the security perimeter, and the tooling have all entirely shifted to the cloud, are we just holding on to hardware habits out of pure nostalgia?
That is a great question to ponder.
Something to think about next time you stare at that permission-denied screen. Keep exploring the architecture, reclaim your workflow, and we'll catch you on the next deep dive.